let's continue what we have from Thursday, which is the last thing we mentioned on Thursday is instead of plugging into the whole equation, if we know the difference of one group and they ask you to know or to find the difference of another group, they tell you all you need to do is take the difference and multiply to the slope. So whatever the slope, in our case, our slope is the B, right? So basically, again, whatever the slope is, all you do is you take the slope and multiply to that difference. So if you remember the house, which is the size of the house corresponding to the price of the house example, they tell you if we know the difference between the two houses or 150 feet, what will be the difference in price, right? So if we know the difference, they tell you take the difference times the slope. And all you have to do is take that difference times the slope and you will see the difference, okay? So we'll take a look at this problem in a bit, but before we do that, let's take a look at this problem. And again, I know that this problem, if we were to have a face-to-face, if we were to have a face-to-face class, which is our class is face-to-face, but if you were to take the exam on paper, they used to give you, or this is the problem on your final exam. But again, let's take a look at this thing here and what do they ask us to do, all right? So if they give you this, they don't give you the raw data, they just give you the output. So this is our output from our data. Now they actually looking at this output. Can you write the equation of the line? Can you predict the y value if we have an x value? Can you tell me what is the correlation coefficient between x and y? And is the linear relationship between them strong or weak, right? So looking at this thing here, reminder, how do we come up with the equation of the line? For us, reminder that this is what we do is y equal a plus bx. Again, y equal a plus bx is our equation of the line. Make sure that when you're on your calculator, you use option number 8, which is a plus bx, not option number 4. Don't worry about option number 4. Again, I have a few students send me an email that they use the wrong option. Again, if you use the wrong option, the a and the b gonna switch. For us, we're using this option, option number 8, which is a plus bx. The b is your slope. So how do you write the equation of line? Well, all you need to do is extract the a and extract the b and put in their place, right? Put in the a value and put in the b value. Your x and y will stay the same. So the only thing is we take the a and we put in the a, which is 0.3946, plus put the b, which is 3.643x, which is, again, all you do is come up with the equation of line is take the b, take the a plus the bx. That's all there is to form the equation of the line. So if they give you the output, that's what we need is we need an a, right? We need an a and we need a b. That's all we need to come up with the equation of the line here, okay? So looking at this thing here, question with this equation of the line.
Yeah, I have one. Just simple. How do you actually get to the line to find that equation again in the calculator?
We will get that to in the next problem.
Okay, thank you.
Yeah. For this one here, for this particular problem, they give you this output. So they give you this output. So now we want to make sure that you know how to read the output. So the next problem, we will do it how to get to this output. So on the next problem you will see, and I will go in with the next problem. But for this one, just know that given this output, all we do is we take the a and put in the a position, take the b and put in the b position, and that's your equation of the line. This is my a and this is my b. The x and y stay the same, okay? Now, how do we predict the y given the x value is 10? Well, to predict the y, all we need to do is plug in the 10 in where you see the x, right? Which is, again, your equation of line is 0.3946 plus 3.6430. And again, all we do is wherever we see an x, we plug in the 10, which is now we know that if 10 multiplied to 3.64 will give me 36.43. And again, I add them up to give me, if the X value is 10, the corresponding Y value, or we predict the Y value to be 36.825, right? So again, it's dependent on your calculator. Most of the time, your calculator tell you how many decimal place they want it to be. So that's what you have in that sense. This one here, I give it 3 decimal place. The other one, which is again, basically you substitute the Y in for the X in, instead of put the X, you put in the corresponding number, right? So looking at this thing here, how do we know what is the correlation coefficient? Reminder, the correlation coefficient is this number here. This R, don't worry about R square, we're not using any R square here. So again, this R is your correlation coefficient. So if they ask you for a correlation between X and Y, again, the correlation between X and Y is 0.0641 or 642, which is, again, this is your correlation coefficient, the correlation between X and Y, okay? So your R value is your correlation. And now, is this a strong correlation, right? Is the strong correlation meaning, again, it's strong linear correlation? Is this form a straight line, for say? Reminder, the R, in order to know if it's a strong positive linear relation, your R have to be close to 1, right? Reminder that the answer, the result for R can only be -1 up to +1, right? Anything between -1 and +1, that will be your R. If your R is close to -1, then we say that they have a strong negative linear relationship. If it's a R is close to +1, we say there's a strong positive linear relationship. But in this case, is this 0.06 close to 1? Well, not quite, right? 0.06, if you think in terms of 1 is 100%, this is only 6%, right? Which is, this is close to 0. And again, reminder that the interpretation is, if it's close to 0, we say that they have a weak correlation, right? Or weak relationship. And looking at this thing here, we can say they have a positive relationship. It is kind of, trend to a positive side, meaning slow increase, right? But beside that, it's very close to 0, which is there's no relationship, there's no straight line that we can see. Okay, most of this thing here probably will be scattered. And again, I don't have, this problem, they don't give you the raw data, so you don't really know how your scatter plot will look like. They just give us the output. So from the output, we will say that this thing here is where we have a weak relationship. Okay, so that's your correlation, which is the number, the R is your correlation. And on Thursday, I told you, don't worry about the formula. Your calculator can give you that R. Okay, so given this thing here, question with this particular problem here. Now, going back to this problem.
Mr. Chair, I have a quick question.
Yes, ma'am.
So if it's like 0.5, then at that point it's stronger, or do you just have to kind of do the math to see which number that is closer to?
It's still weak. Again, in order to be strong, it has to be 0.95 or 0.97 or 0.99, something close to number 1.
So it has to be obviously close. It won't be like in the middle, like we're gonna know. Okay.
Yes. If it's like 0.5, which is 50%, then
right,
you just say that they have a relationship. It's not strong. It still, there's a linear relationship, but it's not going to be strong linear relationship. When it's like obvious, like the next one you will see that is very obvious, like 0.95, where it's very close to 1, then we say it's strong linear relationship.
Okay, thank you.
So looking at this thing here, this is the problem that we stopped on Thursday. And I asked you guys, see if you guys can answer this 3 questions, right? So in order for us to answer B or C, we need to have the regression line, right? The equation for this regression line. So in order to do this, a reminder, ladies and gentlemen, what do we need? Well, we need to put our data, right? We need to put our data into our calculator, which is looking at this thing here. This is what we have is, again, in order to see the output from the previous problem, first we need to put in our data, and most of the time, the first data will be your X, and the second data will be your Y, or L1 and L2, okay? So in order to put in your data, we need to hit Stat and then Edit, right? So again, let me edit this thing here. Let me clear my data. So my L1 is clear and my L2 is clear. So again, which is go L1, and let's just put in this data, bear with me here. So I have 3.92, 3.89, 3.95, 3.91, 3.8, 3.68, 3.55, 3.6, 3.47, 3.38, 3.35, and 3.35. So again, I have 12 data, which is, those are my 12 data for my 30 years market, interest for the mortgage. And again, I need to type in the 15 years as in my L2 or in my Y item, which is 3.2, 3.16, 3.2, 3.14, 3.03, 2.95, 2.85, 2.86, 2.78, 2.69, 2.66, and 2.66. So make sure that your data are matched, meaning you have 12 data on L1, you have 12 data in L2, right? So this case, I have 12 data here, 12 data here, they all match. Now, once you type in your data, this is reminder, this is what you need to do, hit Stat again and go to Calculate, which is CALC. And then, like I mentioned, don't worry about option 4. We are not using option 4. We have to go down to option 8. We have to use this item here, the link regression A plus BX. Again, we're using the link greg A plus BX. And again, if you have 84, which is you press enter, they tell you that L1, L2, which is this is what we have, and all you need to do is go down and click calculate. And again, this is the output we have, and which is, you can see the R right here, the R right here is 0.996, which is 0.996. That is very strong positive linear regression, right? And so again, this is the output we have. But if you remember last time, if you hit zoom, for those of you, if you hit zoom and you go down to zoom stat, if you hit zoom right here in the center and you go down to zoom stat, you can see, oh, let me turn this thing on, sorry. If you have the screen I have, make sure you turn on your stat plot. You just have to turn on your stat plot, which is again, so let's go back to this thing here, just to remind the 11.1, right? 11.1, if you look at this scatter plot, everybody see that it's basically on a straight line, right? That's what the correlation tell us, right? The correlation tell us that all of this point is basically on the straight line, and looking at this thing here, you know, just a few points off the line, but it's basically on that linear line, right? So again, that's what we have. If you look at this thing here, and you're looking at if you look at your output, right? For those you who in 83, you have to type L1 comma L2. And again, the R right here is 0.996, which is, as you can see, is very strong positive relationship, right? So this thing here tell us that all of our point is on a straight line. But to go back to our problem, how do we come up with this equation or this regression line? Which is, again, all we need to do is take the A and take the B, and using this formula here or this equation here, which is, again, my equation will be y equal to negative 0.3351 plus 0.894x. Again, the x and the y stay input. This is what we have, which is my A item, and this is my B item, which is the slope. Okay. The other thing, I think someone sent me an email before. Class. I want to point out that on your homework, they ask you to draw the equation of the line. They ask you to draw a line on your item. So again, let me show you that if you were to, because they ask you to place the line, the regression line. So if you have this equation, ladies and gentlemen, if you have this equation and you want to draw a line on your graph, on your calculator, hit y equal to, if you hit y equal to, and then you type this thing in, you type negative 0.3351 plus 0.894x. If you type it, your equation that you found, and you hit graph, if you type it in, this equation that you found, and you hit graph, your graph, they will draw that line for you. Everybody see that this is the line that you have to put in your, if you have a Connect Math and they ask you to draw a line, you can use this equation and type it in the y equal to, which is your y equal to, and you just type in your equation, use this x as your item, and then if you hit graph, they will place the line for you, so you can see that it's not from the middle of the item go all the way up. It's have to basically, this line have to fit most of the point, which is, again, as you can see, I mentioned most of the point is on the line, and that's why the regression of your line, the R is very strong in the sense that is 0.996, almost equal to 1. Okay, so again, question here in terms of how I find this equation of the line, or how do I find that item that I have there. So looking at this thing here, how, if 30 years, the difference is by 0.3%, how do we find the difference in the 15? Which is to go back to the item that they tell you that if we know the difference of one group, to know the difference of the other group, all we need to do is take the slope, which is 0.894x, right? This is my slope and this is my x. And if I know the item of one group, all you need to do is take the slope and multiply to that difference. So if you take 0.894 multiply to this difference, then all we know that, again, if this thing is different by 0.3%, then the 15 years will be the difference in terms of 0.2682, right? A little bit less, which is, if they ask you for 2 decimal places, it will be 0.27%. Okay, so again, that's the idea that they tell you that if we know the difference of one item, instead of plug into a calculator or plug into the formula and then subtract from the original one, we just take the slope and multiply to that difference. Okay, and again, how do we predict the 15 years rate if we know that the 30 years rate is 3.5? So looking at this thing here, we don't have any 3.5 in the 30 years mortgage, right? We have 3.55 and so on. So if we have this rate, what is the corresponding predicted rate for the 13 years? Well, based on our equation, we can plug it in, which is wherever my x is, I plug in the percentage, which is 3.5. And again, if I multiply it out and then subtract, because of the minus sign, subtract, I will see that the 15 years will be 2.7939. Okay, but again, looking at this thing here, everybody see how we using this raw data to find the output of this one here, right? How do we get this output from the raw data? Reminder, you have to put in L1, L2, and then again, you use the option number 8, not option number 4, option number 8, so that they give you the output of the A and the B. If you use option number 4, the one thing that they swap is your A and your B, okay? So again, don't worry about option number 4. Just keep in mind that we use an option number 8, okay? So first of all, question with this particular problem here in terms of part A, part B, and part C. Well, let's try one more, and let's say if they give you this thing here, they say a sample of 10 households will monitor for 1 year. The household income in thousands of dollars, right? So again, the unit of the income is in thousand. Keep that in mind. And the amount of energy consumed is in 10 to the 10 power of joule, right? Will determine the result as follow, right? So reminder that this 31 is 31,000, right? 31 here is 31,000, 40,000, 28,000, 48,000, and so on and so forth, right? So looking at this thing here, as you look at A, B, and C, you can see that it's very similar to the previous, in terms of the previous problem, in the sense that they ask you for the line, predicted line or equation, right? Compute the least square regression line for predicted the energy consumed from the income, which is again the consumption, which is again this is your Y, which is your predicting item, and your X is the independent item, which is that's what we plug in to predict the energy, right? So looking at this thing here, based on this thing here, again, in order to come up with this equation, we need to have this output. So to have this output, the only thing is, let me move my calculator so that you guys can see the data to enter. Again, to have this output, you have to, again, go back to your L1. And again, make sure to clear and not delete. Let me clear my L1 and L2. So again, my L1, you just type in your income, which is again, the only reason why they put in the unit of 1,000 is when you type in your data, you don't have to put in 31,000, right? We just put in the number. So again, 48, 195, 96, 70, 100, 145, 78. I have 10 data. So now let me type in my L2, which is 16, 40, 30, 46, 185, 98, 94, 77, 115, 67. So again, those are my data, L1, L2, and again, if you want to find a scatter plot, you just click zoom and you go zoom stat, right? Your scatter plot, that, right? So that's your scatter plot that you have. So looking at this thing here, we see that there's some outlier up here, right? There's some small outlier or some item is not really in this item. But again, looking at this thing here, to find the equation, we have to go to calculate and go to option number 8, right? We hit stat, we go calculate option number 8, and then your L1 here and L2, which is now you calculate. And if you calculate, you can see that this is what we have. Is this what we have? Did my data wrong? 48. My data is wrong here. That's why I have an outlier. Is 195. It's not 19. Yeah. So this should be it. Yeah, it's that. this look like more like it. This is what we should have. The A is 2.88, the B is 0.8894, and this thing here should be, again, I remember is very close to one, very strong linear relationship in terms that the more income we have, the more energy we are consuming. So basically, the more income, probably they have a bigger house. So if they have a bigger house, maybe they spend more on their energy bill, right? So again, looking at this thing here, remember to come up with your equation of line, all we do is we take the A plus the BX, right? So again, the A is from the A item and the B from the B item, your X stay the same. So everybody see that, does everybody have this, this equation of line here?
Yes.
All right. So again, that is how easy to come up with this equation of line. Now, they ask you is if two families different in income, meaning one family have, let's say, 40,000, the other one have 52,000, right? The difference in 12,000. By how much would you predict that energy consumption would be different by? So if we know the difference of the income, and we need to know what is the difference in energy, again, they just tell you that instead of plug into original item and then plug in another number in and then subtract them, well, all we need to do is take the slope, which is the slope is 0.8895, times the difference. But the reason why I mentioned to you guys that this item, the income is in thousand. So when you plug it in, ladies and gentlemen, you don't plug in 12,000 because the unit that we have here is already, it tell us that it's in thousand. So when we plug in, we can only plug in 12. Because again, like I mentioned, because each of this item is in thousand, so to correspond to the unit that we have, instead of plug in 12,000, you have to plug in just 12. Okay, so to correspond to our individual data here, our individual data is in is mentioned in thousand already. So again, we don't plug in the 12,000, we only plug in the 12. Okay. So if you plug in the 12, you can see that the energy will be 10.674. If you don't plug in, if you plug in the 12,000, it will be 10,674. You know, it's kind of true. I mean, this thing here, as you can see, none of our data for our energy, none of our data is in thousand, right? All of our data is in you know, the joule unit. So again, you have to base on the data that they give us, because they tell us that each of this thing here is in thousand. So instead of plug in the 12,000, you can only plug in 12. Okay, we correspond to the information they give us. And again, if you can find B, C should be very easy, because now all we need to do is we plug in the income, right? We don't have any family have 50,000 income. We have 48 and 40, right? We don't have the 50,000 income. So now we predict if we have a family have a 50,000 income, what will be their average energy consumption, right? Which is, again, if we do this, which is all we do is we plug in the 50 where the X is at, and then you just multiply them and then add them. So we expect, right? We in average, that family with the 50,000 income should use 47.358 energy consumption each year, right? So again, this is the idea, right? The idea is if we have the raw data, can we come up with the equation of the line that fit that data? And then from that data, can we predict a future value, or can we predict if we have a given criteria, can we predict the other item? Okay. And again, that's
question real quick.
Yes, question.
How come in part C of this question, we have to do the full equation, where in part B, all we have to do is multiply 12 times the slope?
Because they tell you this is the difference. We just estimate the difference. Given the difference, it's basically this thing here is, if you want to do the whole equation for part B, then you have to do, because we want to know what the difference is. So if you put the 12 in the whole equation, you have to add this number too. And then you have to do another one for 0, because we want to know what the difference, let's say from 0 to 12, what will be the difference between the other one. So basically, if you go back to, if you go back to this idea here, they tell you that the shortcut, right? The shortcut is, if we looking for the difference of 1 unit, and if we know the difference of 1 unit, then we don't have to use the whole equation, and we just take that difference times the slope, okay? So in the sense of this thing here, if we know the difference of 1 unit, then we just need to do that. If you do the other way, this is the, give me 1 second here. If you do the other way, in the sense that, if you do the other way, reminder, this is what you have, right? Your equation is y equal to let's say 2.88. Hold on, let me just copy this. So let me delete. Give me 1 second here. All right. So this is your equation right here. So help me out here. So this is your equation of the line. So if you were to plug this thing in, and they say that if you were to plug this thing in for the 12, if you use this whole item, right, like this, right, what do you get? You will get, if you plug like this on your calculator, do you get 0.8895 times 12? Do you get 13.5567? If you plug that in your calculator, do you get that number? If you plug in 2.8827 plus 0.8895 times 12. Does everybody have that number?
Yes.
Okay. So this number tell you that if we were to have 12,000, the predicted value will be 13.5567, right? But they ask us, what do they ask us? They ask us, well, the difference between among the two family, right? If you plug in the 12,000, you tell me that, okay, if a family have an income of 12,000, we will predict the energy consumption is 13.5567. That's what we did over here. So in order for us to know the difference, do you see that we have to plug in this item here, which is you have to say, well, if a family, which is 2.8827 plus 0.8895 times 0, right? So, what does it mean? This item here, which is this item, tell me that if I times 0, meaning again, the difference between the first family, let's say the first family doesn't have any income, the second family have 12,000, right? The difference between the two families have 12,000 income gap, right? So I just say the base is 0. And now if I do this thing here, you see that the number will be this thing here, because again, 2.8827 plus this number, this times 0 is just 0. Meaning it's tell me that now, in order for me to find the difference, I have to take 13.5567 minus 2.8827. So help me out. Take that two number. 13.5567 minus 2.8827. If you type that in your calculator, do you see that the answer is 10.674?
Yeah.
So the idea is, instead of doing that, right? Because they tell you we have two different items. We have two different items. So instead of doing one item and another item and then subtract, because they ask you what is the difference between the two. So they tell you, instead of doing this two item and then subtract them to see the difference, well, all you do is you just take the slope times the difference. It will work out the same. It's just basically the shortcut in terms of doing this, for both items, which is, the shortcut. Like I mentioned earlier, if you want to, if you plug in, let's say this is 52 and this is 40, right? If you want to really do it, like, do you agree that the first family have 52,000, the second family have 40,000, meaning the difference between the two is 12,000, right? If you type this number and subtract them, you will end up with this item right here, which is the difference is basically the slope times whatever the difference is. And that's
so I understand. I just want to make sure I'm understanding what you're saying. The reason why we can use the shortcut on part B of this question is because it's asking for a difference.
Yes.
And the reason why we can't do it on part C is because it's asking you to predict.
Exactly.
So differ and predict are the key words in this situation to determine what you're supposed to do.
Yes. To be short, yes. So if they ask you to predict a value, you have to predict the y, and to predict the y, you have to plug into this equation. Yes. And if they give you the difference, then there is a shortcut which is fine. Take the slope times the difference. Yes.